All right, guys, we're on the back side of day 9 notes, and we're talking about angle of elevation and angle of depression. Okay, so super important that we put the angle in the correct spot. Okay. All right, so number 1, it says a man was parasailing over or above a lake at an angle of elevation. All right, so as soon as you see angle of elevations, that is inside at bottom. Okay, so right here, that's your angle of elevation, right? And that is 32 degrees. From a boat as modeled in the diagram below. If 129.5 meters of cable connected the boat to the parasail, so if the boat is connected to the parasail, that cable is 129.5 meters. How many meters to the nearest meters, there's your rounding directions, above the lake? So above the lake is our height, which would be this, a vertical piece, and that is what we're trying to solve for, okay? All right, so we know we are reading from the 32-degree angle. X becomes our opposite. 129.5 is our hypotenuse because it's across from the right angle. Some old horse caught another horse, taking oats away. O and H uses the sine trig function. So sine theta equals O over H is our formula. Keep sine. Our angle, of which is theta, is 32 degrees. Opposite is X. Hypotenuse is 129.5. We are solving for a side, so we put this over 1 and cross multiply and end up with X equals 129.5 times the sine of 32 degrees. Since it's X equals, we type it right in. And we end up with 68.6245 ... They said nearest meter, so no tenth, hundredth, thousandth, so no decimal places. All right, but the 6 is going to round that 8 up to a 9, and so we'll go ahead and say that X equals 69 meters. And that is the height of our little parasailer above the lake. All right, number 2. It says at the top of a lighthouse, T, okay, is 215 feet above sea level. So above sea level means that's the vertical piece, so that's 215. Okay, is shown in the diagram below. The angle of depression, you guys have to remember it's at the top, and outside the triangle. And you have to form a nice dashed line here as your line of sight. So you're basically pretending you're the person at the top of the lighthouse looking out. And all of a sudden he sees a boat. Okay, so he looks down to see the boat and he's looking down 26 degrees. Okay, and determine to the nearest foot. So there's our rounding directions. The horizontal distance. So horizontal is this piece here that goes from left side to right side. All right, from the boat to the base of the lighthouse. All right, so the one thing we have to watch out for the angle of depression. All right, it's a little bit trickier than the angle of elevation since the angle is not inside of our triangle yet. Okay, basically you're remembering that you got that Z shape with your parallel lines and your transversal here, and you're going to take that 26 and you're going to go ahead and put it now inside your picture. Now we're reading from this angle inside our picture because we always read from an angle when we use trig. Okay, we always read from an angle inside the triangle. So now that that 26 is in there, we're not really using this one up here. Okay, 26 across from it, this 215 would be the opposite side, and our X represents our adjacent side. And so we're going to be using tangent. So tangent theta equals opposite over adjacent. Tangent of 26 degrees equals my opposite over my adjacent. Okay, we are solving for a side, so we cross multiply, and we end up with 215 is equal to X times the tangent of 26 degrees. We're going to go ahead and divide by the tangent of 26 so that we get X equals. Okay. All right, type it in. 215 divided by tangent of 26, and we end up with 440.815 ... They said to the nearest foot, No tenth, no hundredth, no thousand. So nearest whole number is what they want us to round to. And that's going to round to 441 feet. And that's the distance from the boat to the bottom of the lighthouse. Okay. All right, let's take a look at number 3. This one's a little bit tricky because there's no picture. So it says a ship on the ocean surface. So here's my water. Here's my ship. Okay. The ship on the ocean surface detects a sunken ship on the ocean floor. So let's say that this is our ocean floor down here, okay, and that there's a ship down there. All right. In order to detect it, can't detect it right straight below it. It's detecting it at an angle of depression of 50 degrees. So our sunken ship, okay, is somewhere over here, okay, laying on the bottom. Well, what happens is that this boat is looking straight out, and then all of a sudden it has to look down to see this one, and it's looking down 50 degrees, okay, because it's at the angle of depression, which is outside of our triangle. In fact, I'm going to draw the rest of our triangle so we can see that that 50 is actually outside of it. Okay. The distance between the ship on the surface and the sunken ship on the ocean floor is 200 meters. So from ship to ship, okay, which is this diagonal line segment here, which is really our hypotenuse of our right triangle, that's 200. Oh, I put a degree symbol, but it's not degrees. 200, if we want to put a label on it, it would be meters. Okay. All right, if the ocean floor is level in this area, how far above the ocean floor? So above the ocean floor is this vertical piece here, and so they want to know that piece. To the nearest meter, there's our rounding directions, is the ship on the surface. Okay. So how far above the ocean floor is the ship on the surface? All right, so again, this is an angle of depression question, which makes it a little bit tricky. We have to take that 50 degrees, okay, and realize that we got our Z shape here with our parallel lines cut by our transversal, and we're going to put the 50 degrees in here and no longer use this one up here, okay? Therefore, we're reading from this angle now of 50 degrees, and X is my opposite, and 200 is my hypotenuse, and O and H make sine. So we got sine theta equals O over H. Keep sine. Theta is our angle, which is 50 degrees inside the triangle. O is X, hypotenuse is 200. Okay. We are solving first side, so again, we're going to cross multiply. And when we do, we end up with X equals 200 times the sine of 50. Okay. We type it in, and we end up with 153.2088 ... They want to know to the nearest meter. Again, there's no tenth, hundredth, or thousandth, so no decimal places. And so the 2 is not going to round my 3 ups, and so we'll say 153, and we are in meters. And there's our answer. Okay. All right, let's take a look at number 4. It says a man who is 5 feet 9 inches tall casts a shadow. All right, so we got a man. He is 5 feet 9 inches. Casts a shadow. Shadow is on the ground, and his shadow is 8 feet 6 inches. Assuming that the man is standing perpendicular to the ground, so there's my right angle. What is the angle of elevation from the end of his shadow to the top of the man's head? And there's the right triangle. You guys can see it. Okay. They said angle of elevation, so this is an easy one. Okay. They want to know this angle right here. Inside the triangle at the bottom is always where the angle of elevation is, and therefore we don't have to move it, okay, like we do the angle of depression. All right. So again, we'll be reading from this angle that we're trying to figure out. The 5 feet 9 inches, the height of the man, is our opposite side. And the length of his shadow down on the bottom is our adjacent side. And so we'll be using tangent. So tangent theta equals O over A. We'll keep tangent, and theta is our angle, which is what we're solving for. So I replaced it with an X. Okay. All right. So 5 feet 9 inches. What we're going to have to do is we're going to have to convert that. We can't have feet and inches. Common mistake is that you call it 5.9, which is not correct. Okay. Because inches are not out of 10, inches are out of 12. 12 inches make a foot. And so that's why you can't do 5.9. All right. What we do is that we say 1 foot is equal to 12 inches, and therefore 5 feet would be equal to how many inches? Okay, so basically it's just a multiplier, and so when we do 12 times 5, we end up with 60, okay? Plus the 9 inches that he was, because he's 5 feet 9 inches, not just 5 feet, and we are going to change his height to 69 inches, okay? We're going to do the same thing with his shadow. So 8 feet is equal to how many inches? Okay. So 8 times 12, let's see, what is that, 96? Okay, and then we have to add 6 more inches because he's 8 feet 6 inches. So 96 and 6 make him 102. So we're going to get rid of this, and we're going to use 102 inches here instead. All right, so now we can go ahead and replace our opposite with 69 inches divided by our adjacent, which is 102. We are solving for an angle, so be careful. We have to do x equals tangent inverse of 69 divided by 102. Okay. Hit second tangent to get the inverse, and we end up with 34.077195 dot, dot, dot. Rounding directions, guys, up here said nearest tenth of a degree. So because they said tenth, that's the first decimal spot. Look next door, and it's going to change it. And we're going to say x equals 34.1, and it's an angle, so degrees. And we are now finished. All right, so hopefully that helps. And I'll see you guys on the next day of notes.